Hey guys, welcome to my channel. So tonight's video is going to be about these cap dumps. This is a custom one that I made for one of my customers and friends. This is 100 volt at 10,000 each, so 100 volt at 20,000 mics. And it's for 12 volts, so we have these zingers right here. So we have 15, 16, 20, and 24 that we could test out. And then we're going to be running it with this motor. This is my newest kit motor. I did a video, my previous video was on that. You guys could take a look at that if you're interested. Kenergy.store. So we have the 12 volt input. So here's our 12 volts. Red and black are running the motor, and then we have yellow and white are the output. So it goes right into the cap dump, and then through the cap dump into this battery, which is 12.2 for charging. Then we have a 5 amp meter, and so you kind of see the difference in it. So yeah, I have different sizes. This is my normal size. This does 12 or 20, 24 volts. This is actually the same size capacitor, just lower voltages. These are 35 volt caps at 10,000, and then if you want up to 48 volt, you'd use these bigger ones, and these are 80 volt at 10,000, so you're 40,000 at 80 volts. And so this one was a little more custom. He's going to be putting probably 1,000 volts or more into this one, so I suggested 100 volt capacitors versus 25 or 35, because my 35, these normal ones, they do 500 volts no problem. I've had them up to almost 1,000 volts, but these big ones definitely do a lot better for that kind of voltage coming in. So let's so we have this voltmeter right here, and this is going to show you the voltage coming in from the cap. So let me get this set up here. So battery voltage, capacitor voltage, and we're going to start off with the 15 volt zener. And then we have the green neon light that shows you when it's discharging. So if you don't have an amp meter, every time this goes, it's obviously firing. So let's fire up this motor, and you can see it charging. So this one triggers between 15.5 and 16. It's hard for the voltmeter to catch up, but so at 15 volts, it's discharging pretty quickly. And as we go up in zingers, there'll be changes. So let's switch these out. Let's go up to 16, because 15 was about 900 milliamp discharges. So this is our 16 volt zinger. So now we're just a hair over 1 amp, so we're about 1.2 amp discharges, and we're discharging about 17 volts, a little over 17.2 average. So you can see it slowed down a little bit because this is taking more charge. So let's go up to 20. These are the more common sizes. So if you have a big motor and it's discharging too quickly, you could always just come up in voltage, and then you'll get more energy out. So here's the 20. So you can see it slows down. So if you have a bigger motor, you could just increase the voltage and then let it discharge a lot more energy. So now we're discharging 20, 21, somewhere in there. So we're almost to 2 amps. We're about 1.8 amp discharges. So let's get up to our last voltage. So for these 12 volt cap dumps for charging 12 volts, I usually do 24 volts zingers is the max. So if you want more power, you just put more capacitors on. Alright. So now we're about 2.5, maybe 2.6. You can see we're discharging. 25. Definitely need some faster meters. So you can see the light going in tandem with the discharge, so it's really nice. We can see how much power it is. So now we're at 24 volt zener, so we're doing basically 25 volts at 2.5 amp discharges, so that's quite a bit of energy. So yeah. So if you guys have any questions, just leave them in the comments. Don't forget to check out my store. Thanks for watching.